Have you ever wanted to add new syntax to a language? Python and JavaScript add new syntax sometimes, which is pretty cool, but what if instead of hoping they add something you want, you could just add it yourself? Python lets you do operator overloading, which can kind of let you do this a little like how pandas has special behavior for the index syntax, but you're still stuck with the operators that are already in Python. But those operators are cringe! You want to make your own beautiful custom syntax. For example, let's say you're writing state management code for a vending machine. It starts out in the idle state, and from there you can pay, which puts you in the paid state. And from there, you can either refund to get your money back or select an item, which both put you back in the idle state. Here's how you could implement this in Python. There's lots of boilerplate since we have to keep track of this state enum as a mutable field and throw errors whenever an action is invalid for the current state. Lots of junk that makes it hard to see the important bits. It'd be really nice if we could make our own custom syntax that's less noisy and takes care of the repetitive parts for us. Ooh, look at that. It's so concise and Pythonic. So much better than what we had to write by hand. Definitely one of the syntaxes of all time. You asked Guido to put this in Python, but he hasn't gotten back to you yet, so he must be really busy implementing it for the next version of Python. But while you're waiting, is there anything you can do? If you're really dead set on using your syntax, you could just write a function that takes in a string written in your syntax and then parses it, and then you could do whatever you want. But you'd have to implement a whole Python parser to break up the bits and pieces of that string, and then dynamically create a class value with dynamically created methods, which would be really awkward. It'd be way nicer if you could somehow leverage Python's parser, and then just have your state machine thing spit out the plain Python code you would have written by hand and have Python run it, instead of having to write your own parser and make some weird class value thing on the fly. This thing that we want, which takes in syntax and rewrites it, is called a macro, because we're making big moves out here. We don't mess with any of that micro nonsense. Python actually does give us access to its parser. It returns something called an abstract syntax tree, which is a value representing the code that it parsed. We could use this to parse our state machine code, and we could also return an AST instead of a string. One issue is that there are lots of different types of Python expressions and statements, so this abstract syntax tree is really complicated, and that's what you have to work with when you're dealing with syntax. I mean, look at that. They got everything. They even got the walrus. What's worse is that even if we do use Python's parser, it doesn't know how to parse our special syntax, only Python's. We could get around this by making our syntax a subset of Python's, but then it's really confusing and we're kind of abusing Python's AST. And even if we do this, it still doesn't help us on the other end, which is somehow getting Python to run the code that we generate. Luckily, there's actually a Python library called MacroPy that helps you do all this. To see it in action, let's simplify a bit by making a smaller macro. Instead of our state machine syntax, we're going to make a macro called fun, which is like a lambda, but you don't need a variable name because you suck at naming variables. This is obviously way less cool than our beautiful state machine thing, but it'll show us how to do macros. Implementing something like a state machine macro is the same idea, but just bigger. Anyway, to implement this with MacroPy, we just walk the AST and replace instances of underscore with temp, and then we use this Q thing to create the resulting syntax. This Q thing is called quasi-quote. It's kind of like format strings, but for building an AST instead of a string. AST literal is how we inject a real value into the syntax we're building. Pretty nice. Now we don't always have to construct ASTs on the way out manually. This makes macros pretty easy, but we still have to know a bunch of AST constructors for analyzing the input syntax, and we still can't use our custom syntax since it doesn't parse with Python's parser. We started with strings, which are really simple and give us a lot of freedom, but they have no structure, so we needed to write our own parser. Then we tried leveraging Python's parser, which saved us from having to write our own, but we had to change our state machine syntax to appease the parser. And now we have to deal with a million AST types. But what if there was something in between? Something simpler and more general than the Python AST, but still with more structure than a string so we don't have to do anything like a parser. Well, how about lists? They're pretty simple, and you can have lists inside of lists for nesting like a tree. For example, a function call looks like this. There's a sublist for the arguments. A binary operation looks like this with the operator in the middle. And here's the whole function definition. The function header and each statement gets its own list. Alright, this is much simpler than Python's AST, but it's a little bit awkward, so we can clean it up a little bit. Like, having a separate list for a function call's arguments is a bit redundant, so let's just flatten that out into one list. And operations like addition are basically function calls, so we can represent them in the same way. Okay, this is looking pretty good now. These are called S expressions because they're pretty sick, dude. And it'd be pretty sick if our macros could operate on these instead of ASTs. For example, here's what our fun macro would look like now. It's not much cleaner, but the big benefits of using S expressions are that we're no longer limited to Python syntax, which is important for our state machine macro, and we don't have to know a bunch of AST types, which is important for our sanity. But now it feels like we have two versions of Python syntax, the surface syntax that people actually write in, and S expressions for macros. So macro creators will have to constantly be converting back and forth between them in their mind. Okay, hear me out. What if we just made the surface syntax S expressions too? So people would be writing their code as S expressions the whole time, and it'd be natural for macros to deal with S expressions since that's all there is. We don't even have ASTs. Okay, but writing code like this would be really annoying, so let's clean up the syntax a little more. We can get rid of those commas since there's no ambiguity about the boundary between elements. Everything is either atomic or surrounded by brackets, so white space is our comma. And we can make these brackets parentheses instead because parentheses are less weird. And all of those quotes are kind of redundant now too, since variable names can't have spaces, so we can get rid of those. Alright, congratulations, you just invented Lisp. Unfortunately, some guy beat you to it in the 70s. There are lots of parentheses, but the benefit is that the data model for syntax is super simple, which makes macros really easy. For example, here's what a lambda that adds 1 to its input looks like in Lisp. And here's how we'd build this S expression syntax as data. That quote thing means I want to make an S expression for the variable lambda as data, not literally do a lambda. Kind of like how we wrapped variable names in a string in Python. In fact, that quote thing isn't just for variables, we can use it on the whole list. In general, that quote captures the whole next S expression as data instead of literally evaluating it as code. This looks just like the S expression in Python. So if we make our fun macro in Lisp, it'll look similar to the MacroPy implementation too. And similar to that Q thing we had in MacroPy, we have quasi-quote in Lisp too. The backtick is for quasi-quote, and the comma is like AST literal for referencing actual values and injecting them into the S expression we're building. And look at that! In just a few lines, we added new syntax to Lisp that looks just as real as the built-in syntax, and we could use whatever syntax we want since the Lisp parser will pretty much parse anything. So our beautiful state machine syntax is back on the table, with a bunch of parentheses. If you squint, I guess it's still nice. Speaking of custom syntax, there actually isn't anything special about Lisp's built-in syntax. Pretty much everything built into Lisp is just a macro like the ones we wrote. There are only actually a few built-in operators. And if you think this is a lot, remember Python's AST. Everything else, including stuff like def-var and even def-macro itself, is just macros on top of core forms. It's macros all the way down. Nice syntax like def-var and def-macro, and even stuff like and or, which would normally have to be baked into the compiler, are just part of this standard library and could be implemented by anybody. So the compiler pretty much only has to know about those 25 special operators and how to expand macros. Pretty cool. Anyway, back to our fun macro. Making macros is pretty easy now. You might even go so far as to say it's fun. But you know what's not fun? Bugs. And this macro has one. What would happen if temp was used in the body of the function? Uh-oh. The lambda argument temp shadowed our local variable, so we'll end up doubling numbers instead of adding them to 100. That's annoying. I guess you could make a random name every time instead of temp, but that'd be kind of annoying too. It seems like our typical idea of variable scoping doesn't work here. We want some kind of mechanism to distinguish between variables introduced by a macro and variables supplied as an input to the macro so they don't collide with each other. This is called macro hygiene, and Lisp stinks because it doesn't have it. But hygiene is a whole can of worms on its own, so I'll leave it out of scope for this video. You see what I did there? It's like a double meaning because I said